Okay. Hello, guys. My name is Luka. I'm one of the event organizers for GDG Osijek, and this is our first online meetup. And we are very happy to see so many of you join us here today. We're very glad to see that so much people is interested in Android and especially in Compose. Today we have a special guest. It's Ian Rumac from Zagreb. He's been an Android developer for 7 years, and he has really extensive knowledge of the Android. And today he's going to tell you more about this new modern way of building Android UI with Jetpack Compose. Ian, the stage is yours.
Thank you, Luca. Hi, everyone who's listening. I'm Ian, as Luca said, and I'm here today to talk to you about Jetpack Compose. You've probably heard about Jetpack Compose during the last year. I think it's been publicly announced at Google I/O, and there's been some talks around and about it, but we still don't have it in our apps. We're not trying to get it to production, so what's happening? So first off, everyone who is an Android developer knows that developing Android is a joy. You can use Kotlin as a primary language. You can do amazing things, and there's a ton of libraries and huge community support. It is a pain when it comes to developing the UI part, because UI part is complex. It's a legacy system. It's built upon views which have been which have been created, I don't know, like 10 years ago or whenever Android came out, nearly 11. So in this way, after this, inspired by Swift UI and Flutter and React and similar, now we finally have a simple framework that's similar to that. It's basically a new age for Android developers. It's a declarative UI toolkit, and that means it allows you to build UIs by declarative programming. It consists of Android Studio, which, well, the toolkit doesn't consist of, but you need to use new Android Studio 4.1, the canary preview, to use it. And it consists of a compiler plugin, which enables those add composable annotations and the whole behind-the-scenes magic, and of a bunch of libraries like Foundation, Runtime, Framework, Material libraries, and such. And all those libraries actually contain a bunch of Kotlin functions. And those functions are akin to what you would call views currently. And they allow us to build UIs by nesting them. So we have a bunch of functions, we nest them in a tree, and we have magical rendered UI. It is made to replace and both plug in with the current UI framework. So you can have a whole activity in Compose, you can have the whole app in Compose, or you can have just some views. It can even generate, or they plan to be able to generate normal common Android view by a generate view annotation. But I don't think that still exists, so we're gonna have to wait for that. So what do I mean by replacing the current system? I mean by, instead of having a custom view group like a linear layout, which has some image and texts, and you have to write an XML for it, you have to give it IDs, then you have to inflate it, you have to write a method to set those, and then you have to set those. You can just write a set of Kotlin functions like this. You just create a function called our component or whatever, you pass the arguments, and you define what you want inside using those nested functions. So you, for example, set a column, and you want an image. So you set an image, pass in the URL, you create a row, and you add it to children's, which are texts with your titles and subtitles. But the main thing here is the add composable annotation, which means this function is composable, and it can only function inside a Compose scope. We'll come to that later. But why do we need now a new UI framework? Haven't we had enough already? Like we had views, then we had fragments as UI framework. Then there was Anchor for a while, and someone made Splitis, but there's even Lito, which is pretty similar in a way to Compose. But yeah, the current state of UI in Android is still based on good old views. And they are based on imperative programming. And Well, imperative programming itself isn't dangerous. I didn't say that. But when you make Android views and use that old Android toolkit, you have like a billion states where you have to manage everything. You have to set everything to views. You have a bunch of callbacks that call other stuff or set other states, and it's all over the place in different functions. But and some are in XML, some are in code, and there's a ton of inherited behavior. Android's system is pretty old, so there's a bunch of stuff inside it. Like when you take a look at the view class, it's got about like 3,000 or 6,000 lines of code, and everyone inherits the view class, and then you have view groups, and then you inherit view group, and stuff like that. And then you know what behavior is actually going on, and you get weird states which you didn't expect. And there's fragments. I'm not even going to talk about that. And the themes, because theming in Android is also kind of a pain. You get XMLs which extend also others XMLs and inherit their behavior and stuff like that. So basically there's a lot of legacy decisions, and there's also some bad naming. Stuff like spinner, which was, as I remember, named because it's spinned left and right, and now it's a drop down, so everyone is confused when dealing with those. And also, speed is a huge pain point in Android development, because you have to be careful not to invalidate reviews too much times. You have to be careful how you animate. You don't want it to get laggy and choppy. And the worst thing is it lets us be lazy and hack. So when you can't fix a problem, you just hack it in, you set it at state, you force everything. And well, that's good because it lets us hack away whatever we want sometimes, but it's also kind of bad. So we decided this time to keep UIs pure. And what's so good about keeping your UIs pure? Well, the good thing is that the state you give it or the arguments you pass means you will know exactly what you receive, what view is rendered from that function. And it's basically pure functions, so they don't have any side effects except the ones inside them. They don't mutate anything outside of their scope or context. So this way, your UI is basically a pure function that describes your data. You take the data, for example, an app state, which can have a list of some items, and then you wrap those items in something that describes them. For example, you wrap the list in something that describes the list, and for each item, you wrap the item inside a function that describes that item. And since it's already a function, that means we can reuse it in a lot of places. So instead of, oh God, now I have to create a new view group because I wanted to extend this, but I can't extend this, want to reuse this, but I can. No, now you can because it's a function. But it being a pure function also means that we can memorize it. For those that don't know, memorization means that you cache the output of a function for some arguments. So, for example, you could have a hash map containing hashes of arguments for keys and the result of the functions for values. So instead of calculating the function again, you can just invoke it from the cache. And the best thing is that all of your UI is in one place. So you don't have it spread around an XML file, a file with your custom view in it, and another file which inflates it and manages the state. You have it all in one place, so you are not so inclined to make a mistake. And hacking is punished. If you try to hack stuff around like you did with the old view, you'll probably get either recursive invalidation, so constant re-rendering. You might get some issues that will throw out exceptions like out of frame or stuff like that. Or it just will break during compilation because the compiler plugin will warn you that you're doing something that's completely wrong. So let's take a look at some composables. For example, this is a composable function that renders you a column with a network image and a row of two texts. And now we're gonna dive a bit into it. So the UI inside Jetpack Compose is built by describing trees. So for example, let's take the UI on the right. Trees consist of nodes and leaves. Nodes are children of node, which doesn't have any more children. It's the end. And leaf is a node that has children. So no, sorry, node has children. Leaf doesn't have children. Hi, sorry. Did I break?
Yeah, you broke just for a bit, but
Yeah.
you can continue now.
Okay. Yeah. So yeah, where are we? So yeah, nodes are they have multiple children, and leaves don't have any children. So nodes could be groups and functions such as a box, a column, a row, or stack, or a clickable. And leaves are stuff like text or an image, which is the end of the UI tree and doesn't have any children inside or behind it. So for example, on that, looking at the screen on the right, we'd have a column which orders its children vertically. And at the top, we would have an app bar, which is like a toolbar. And then we would have a list. And the children of the list are cards, which itself has, again, nodes such as a column and a row, which arrange their children inside them. And we also have modifiers. Modifiers are like properties. You pass them in as arguments to compose function, and they modify the view based on the order of the functions, based on the order that you chain them in. So, for example, in this order, we chain them, like, set them to a padding, and then fill maximum height, and I'll set it a weight because it's in a column or a row which supports weights. And you have a bunch of stuff here, like you can draw shadows, you can clip them into different shapes. So, for example, if you have an image and you want a star shape around it, you would just add a modifier that says .clip and paste in a star shape. But when you look behind the curtain, it's actually not a tree, because behind the curtain, it contains a data structure known as a gap buffer. And that's basically a long list. Let's say it's a long list of components. And the positional memorization, which memorizes the code position, and we'll get to it later. So we have a composable function. Each composable function has an annotation. An annotation marks them for the compiler plugin. So it's not an annotation processor, because annotation processors can't modify code and can't do the magic that Compose does. So it marks them for the compiler plugin. The compiler plugin then adds a key and the composer context to the arguments of that function. And then each of those functions then has its own key, which is generated by looking at its position in the source code and the hash of its position of the source code. And after that, during the pass, the tree is flattened into the list called gap buffer. And the thing about gap buffer is that it contains all of your items, and it has an empty buffer at the end. So when it passes, when it does a pass, it flattens the children, ordering them. I don't know how they're ordered, depth first, I think. And each of them is saved into the gap buffer, also with its key and with its arguments. So here we have, for example, I can mouse over it. Yeah. Here we have, for example, our column turned into a group with its key, and the column below it also turned into a group with its key, and the images and text passed in with their arguments. Oh, I'm missing the argument for the image. Just notice that. And then each change, every time argument to a function changes, it's committed in a frame. So you actually open a frame, which is like opening a transaction, and then you do whatever changes you want to do on the functions or on the data, the states which you're manipulating. And then the frame is committed, which means the changes are applied. And if, for example, a key at the position changed, so like if now instead of having a group with a key 9002, we had an if else and something different appeared here, we would take that empty buffer at the end of the list, apply it at the current position to overwrite everything inside that group, and possibly add some more space if we need it, and insert the new content here. So let's skip all that and let's show it in demo. So let's build a basic tree. So here, as you see, we have a normal activity, a normal Android activity, but it has set content, which is actually a lambda function, a composable function. So instead of setting a normal resource, you say, hey, here, I'll set the complete content of the activity as a composable function. And we define a material theme. That means we can use material components inside as the children of this material theme. And just show you what we're building, I separated into the network part some basic cocktails API. We'll be fetching a list of cocktails, and we'll be displaying them in a list. Here's the model. Oh, I don't know what happened to formatting, sorry. But yeah, just a note, when you're doing stuff with annotations like retrofit or, I don't know, GSON or something like that, you have to separate your models that use annotations from models that are inside that use Compose, because the Compose's compiler plugin breaks when working with other annotations, apparently. So here we'll just build, let's say, a normal card. Oh, let me put it here. Let's just, for start, add a text that says, I'm in Jetpack Compose. And we'll run it. And as we can see it on the right, hi, I'm in Jetpack Compose. So let's now try and redo the one I had before. So let's make the one from the presentation. And we'll make a new composable functions. We'll call it drink item. And we have to mark it as a composable. So the compiler knows we're dealing with composable functions here. And then we can start building it. So for example, we can have a column. And here we can pass in, if we want, any modifiers on it. And we will define its children. So we defined an image. I'm actually going to define a network image here.
Ian, can I just interrupt you for a second?
Yeah.
Could you possibly change the size of the code just to be a bit larger, because some of the people on the stream can't really read it because of the quality of the stream? Thank you.
Yeah. So, okay, instead of an image, I'll pass in the, is it good now?
Yeah, it's much better.
So instead of the image, first I'll start with passing the arguments. So we have two texts. We'll have a drink name. We'll have its description of a kind. And we'll have the image URL. So we're going to pass in a drink name, and we're going to pass in a drink description here as arguments. And then you'll see here, okay, let's move this, and we can make a drink item with a name, I don't know, super cocktail, and description, awesome drink made from stuff. And let me grab a random picture from Lauren Pixum, let's say. Just a second. Okay, got it. And I'll set it here to the network image component with image URL. And build it all. And voila, here it is, an image loaded from the network with 2 text below it. But okay, yeah, and that's just an image. Now let's go and see how we can actually get the contents from the API and display them inside our UI. So we built a basic tree, but to display our content and actually fetch it from the API, we'll need to manage some states. But managing states is real easy inside Jetpack Compose. It's actually been solved so that states are actually composable functions, basically. They're in effect also composables, and they're also saved in the gap buffer, and their changes of the state object are also tracked. So they're introduced by using a state delegate. So for example, we have variable loading, and we assign it by a delegate that says called state. State marks it basically as this variable is prone to changing, and whenever this one changes, we'll have to re-render the view. So we call the state delegate and set it to true. And if while we're rendering, so let's say we have an if else, and this is if the state is loading true, we'll have this rendered. And since they're also basically composables behind, that means whenever the state is changed, we're gonna notice the compiler plugin is gonna notice, or the library is gonna notice a change in the its gap buffer, and it's gonna change the whole composition. So, oh, the frame changed. Okay, let's change the composition, and you get the rendered list. So when do those, how we can track those changes, like setting them when something is set when created? Well, we track them by using some callbacks. Those callbacks are invoked, for example, when the composition, your composable function, is either first rendered, that creates that invokes the onActive callback, and then in order they are encoded like on pre-commit and on commit to set the initial data. And then every time you change the data, the on pre-commit callback says, hey, I'm gonna change this frame now. I'm gonna commit this frame now, commit this change. Is there anything you wanna do? And at that point, the UI still isn't displayed. So here you have a chance to, I don't know, interrupt anything or change anything or invoke a operation that's gonna take a while or something like that. And when the data is changed, on commit is invoked. And at that point, basically the frame is ready to be used and it's rendered. And of course, when it is done, when it's disposed, so when the UI is rendered and the composable function isn't valid anymore, on dispose is invoked, and you're supposed to dispose of stuff here. And the listeners, you might have any observable, trackables, I don't know, whatever. And those changes that only occur in the main thread. So you will get an exception that says not in a frame if you're trying to do something out of the main thread. So just so you know, it's basically like old Android, I don't know, what was it, on main thread exception or something like that. And well, let's see how that states works before going to this. Okay. So for example, you will see in the network module, in the network, I have a retrofit call. I expose an API, and I have a retrofit call which gets by name, which searches all of the cocktails by name. I hard-coded here the variable A because the text field is currently broken in this developer's edition, so sorry about that. And what we want to do here is, let's say we're going to create a page for drinks. So drinks page. And be composable, of course. So we want to have drinks, which is gonna be a state. Sorry, state. Nope. And we're gonna currently make it an empty list of drinks from the network model. And we want to have a list of, want to take the list of those drinks, so adapter list. It's basically like a recycler view, but inside Compose. And what it does is it takes in a list of data, like for example, list of drinks. And for each of those, it renders an item. So for each of those, we'll render a drink item with its dot name, its dot instructions, and the image URL. But currently it's empty. So we're gonna add a loading bar. So if drinks is empty, we're just gonna show a progress indicator. And we're gonna add modifier. Let's add a modifier. We have it, I don't know, fixed size. So let's preferred height for 60 density points. You might have issues if you have custom extension functions like .dpe for density points. It might be sometimes annoying for you because you'll have to choose which one you want. And IntelliJ sometimes misses which one you want. And otherwise, we're going to display an adapter list. Oh, sorry, I didn't use actually the drinks page here. Okay, now here we're gonna have a drinks page. Okay, but we gotta fill out this string somehow. So I have this network class, repository. So this is my network repository, let's say. And I'm on the API. I can't really access it here. I need to do it inside another thread. So we're gonna need to use coroutines. And we can do it in the basic way. So we could do it, I don't know, have a coroutines scope, dispatchers, IO, and then we can do drinks equals repository by name. Oh, sorry, I didn't call launch. Oh yeah, this needs to be a var. Okay, and we could just try running this and seeing what happens. But it's probably gonna throw an out of frame exception. Yeah, it did. I don't know if you can see the exception here. We can't because it's in a coroutine. Okay, but we're not inside the frame currently. So to be inside the frame, let's make an on-commit call. Let's add an on-commit callback, which will take drinks as an argument.
And it will say whenever, what this does is basically whenever drinks changes, so do on active here. So what this means is when this composition becomes active for the first time, we will do our call and we will launch the coroutine. But of course, we're not in the main thread, so we're still gonna get the exception. So we could do like result here, and then we'll do even actually I'm gonna make it a let. And we're gonna launch here and dispatchers.main drinks equals it. And let's run this. Ta-da! But okay, now we don't want to actually do this like that. It's kind of ugly. See, our code is full of everything. But one thing we can do is we can actually extract drinks to another composable function. As I said before, composable functions aren't just UI functions. They're also states, and they're effects, which means they can modify or change a state. So we'll do get drinks from API function, which will return a list of drinks. Sorry, drawing. And then we'll just move all of this nice code here. Ta-da! And we want to know, yeah, also one thing we don't want to do is keep stuff like our network created every time a composition activates. Oh, yeah, I'm not returning. Okay, yeah, I was returning drinks. So yeah, we don't want to create a network, a repository instance every time we want to call the composition is created. So every time we call this, so we'll have to somehow pass it, and we don't want to pass it constantly as a dependency. Like if we created it in the main activity, we'd have to pass it down the drinks page, which means we'd have to pass it down to the get drinks from API call, and that can get annoying. So for that, we use ambience, and I'm going to tell you in a minute about ambience. But we're going to have our drinks result here be the results of get drinks from API. So what happens here is that basically we render everything for the first time. Drinks is empty because it returns the state that's empty list. And then since drinks is empty, circle progress indicator is rendered. But when the state changes, well, when this is created, the onActive is called, the coroutine is dispatched. And when the state changes from the callback of the coroutine, actually from the continuation, then back here, this whole scope gets re-rendered. I'm trying to point to you with my fingers on the screen, sorry. Well, this whole scope is re-rendered, and this group is removed, and this group is shown. So let's see how we can pass in the dependencies now. Well, trees like to grow in nice ambience. So I think, I don't know, because of that maybe, they called it ambient. But ambients are like service locators, let's say, of the Compose world. You provide a dependency or an object which you would like all the children of this node to have access to. And that object is shared among all of them, so it's like a singleton in a scope, inside the subtree you're providing it in. So for example, here I create a drink repository ambient, which is an ambient of drink repository. It will return my network class, but it's not initialized by default. That means that every time we want to use it, we have to be inside the provide scope, otherwise we won't get anything. So we wrap the subtree that receives it in provides, and then we access it via key. What do I mean by that? I mean that we have this provider function, which takes a list of keys and values for these dependencies. So drink repository ambient is a key, and repository is a value. And then further down in a component, we can access it by referencing the key and then calling current, which gives us the current value of the ambient. And here, as you can see, I use remember. I'll explain it in a minute. Let me just open up that code. So let's create our ambient. We're still inside the main activity. Okay, I'll extract these just so they're not in our way. Let's drop them here. Okay, get drinks from API. Imports.
Sorry, Ian. Can you make the font bigger again?
Okay.
Yeah.
No problem.
Thanks.
Okay, this is get drinks from API, and we will take our drinks page. We can keep that here. We're gonna extract it. We want nice code. Okay, imports. Okay, now we have extracted everything. So we want to create an ambient first. So let's make an ambient file, network ambient. It will be an ambient of network as a generic, no, wrong network. Okay. And here we will create an instance of the ambient. So we'll have a network repository. And we will use remember. And remember is also a delegate that says, okay, remember this value and don't change it during any recomposition. So we here will create an instance of our network. Yeah. Okay. And now I have to wrap this in a provider. So that means that I'll take a network ambient, say for the key that is network ambient, I will provide the network repository value to each of to every child inside my scope. So that means drinks page and all of its children will have access to that. And then we'll go into get drinks from API. And here, where is our network? We'll just access the network ambient, but current, and this will give us the current value of that network ambient. And I'll just call the API to access my API. And we'll re-render this. Ta-da, magic. Okay, so this looks a bit ugly. Now, let's talk a bit about modifiers. So I mentioned them before. Modifiers are applied to basically are passed into every function as arguments. Let me just see where my drink item is. Oh, it's still in the activity. I'll just extract it too. Okay, so we'll put in some simple modifiers here. For example, we want the height of this to be, let's say, 300 density points. So we'll set up. Okay, something wrong. Wrong import. So, okay, we'll set a preferred height modifier for 300 density points, for example, and we'll tell it to, I don't know, have a background and have a colors. I made my own colors. Let's see, background. And to the network image, let's add some modifiers. Like we want to, I don't know, to fill the whole screen. Sorry, modifier. And let's add a shape.
Ian,
Mm-hmm.
sorry. Can you just go to the settings and set the font size to be bigger? Because
Yeah,
in every
okay.
file, you will have to zoom in.
Yeah, okay. Make it 22.
Let's try with that.
Okay, let me make this a bit wider. So, okay, where was it? Yeah, we're passing in modifiers. Actually, then we're gonna clip this to shape. So let's clip this to a rounded shape. What it means is that on this view, network image, we're gonna make it wider to fill the edge of the screen. Then we're gonna clip it. And we're gonna set a weight so we can distribute all the items of the column as we wish. Sorry, wrong bracket. So let's set a weight like, I don't know, 3F. And we'll have this text. Let's add it to modifier 1F, and let's add the same to the one below it. Okay. And let's put some spacing in between them, like for 16 density pixels, just so they're not crammed together. And let's rebuild this and see what we get. Oh, okay, ugly as you can see, but you know what? We can make it a bit better. For example, let's go to our list, our drinks page, and let's add it modifiers. So we have some padding, like 16 density pixels, and then we could add some spacing between each item. Okay, and let's style the text a bit. Let's rebuild this in the background. So you can also style text by passing it in text styles. As you saw, there's a material theme. You can access some already predefined text styles by, for example, accessing material theme, typography, I don't know, caption, or let's say H3. Let's see what that looks like. Okay, yeah, better, but also bad. Let's add some padding to this column. Maybe it will make it better. Okay, this is now looking a lot better than before. And as you can see, they're all from the API, and okay, some here break. And I think that we can fix this by clip to parent, but it also might be broken. Let's see here if we can set clip to bounce actually. And here it is, it's clipped. And so yeah, this is a bit of Compose for you. And now let's continue with your presentation. Where are we? We skip this. And yeah, after you've seen this, if you like it, what to do now? You can try it. You have to install the latest Android Studio, the Canary version. And you can use the Create Empty Compose template that's available when you start a new project. So you don't have to add all those dependencies and set everything up alone. You can just have it done for you. And last time I had a talk like this, it was, I don't know, a few months ago. There was different versions. It was version, I think, Dev 02 or Dev 03. And a lot of the API changed since then. So be aware that a lot of your stuff will break. So don't plan on using this long term for now. Just wait for the stable release if you want to have a stable library. And yeah, last time I got some questions about architecting this, and is MVP still viable or MVC? Well, I mean, everything is still viable, but Uniflow-like architectures are the way to go with a framework like this. So just keeping the data flowing in a single loop, let's say like that. Stuff like, Redux or Elm or whatever the kids call it these days, MVI or something. And for now, you got to keep annotations in a separate module, as I said before. And some components are broken more than others. For example, if we tried to put in, I don't know, a text field here with the value of string and callback. Let's just add in a modifier. And no, wait, sorry. Okay, I think my whole emulator now. Okay. And as you can see, there is a text field, but it's not. Or you might even want to make a card with some shadows, and that's going to break too. But that's just living in what life is like in the alpha versions and development versions. So don't worry about that. Just take a look at the release log, change log, and see what's going on in this version, and take a look at the Kotlin Lang Slack and Compose channel. Usually, if anything's broken, people will discuss it there. The team is there. They're really extremely helpful. I think they're probably slowly working on Compose because they're trying to answer everyone's questions there. So don't expect a full-fledged, fully stable library. And please don't go running it production. And if you do, you didn't hear anything from me. I didn't tell you about it. So if you're still not convinced, one last example. When you got to make a list in Android, for example, you need to create a fragment. You need to create an XML for the fragment. You need to inflate it, create an adapter for the list, create a view holder, add an item XML for that view holder, set an adapter for the list, set the manager for the list, set the data to the adapter, and set the data to the view holder. And that ends up a nice big ball of spaghetti and state in 1,000 files. Compared to something like this with Compose. So I think we all can't wait until this is fully released and see all the amazing stuff we can do with it and shorten our code and boilerplate. So no more XMLs. Yeah, we're done with XMLs. We're now doing trees. And thank you. And if anybody has any questions, I'll be on stream. I'll check the YouTube link and I'll try and answer a few. But otherwise, you can ping me on Twitter or you can ping me on Kotlin Lang and Android Chat Slacks or find me whenever. Thank you for your time and hope you enjoyed it.
Thank you, Ian. It was a great presentation. There are a few questions here in the chat. I can read them to you. I don't know if you have it open. So basically, Goran wants to know if you can modify anything in XML combined with the Jetpack Compose.
Well, I'm not sure what you mean by modify anything in XML. You can use XML as resources or drawables and stuff like that from Compose. You can use a Compose view inside the XML and then programmatically compose the functions inside. Or you can generate, you can create a Compose view, write it, and then write a generate view annotation. Let's see, I don't know if it's been added, but let's see. No, wait. Bricks page. Nope, nothing. But yeah, you will be able to generate a normal Android view class. You're gonna be able to, I think, put the Compose view inside XML. And you're gonna be able to use, I think, also normal Android views in Compose. So interoperability is gonna be to the fullest.
Cool. If that doesn't answer your question fully, Goran, you can ping Ian on Twitter, like he said. Another question is from Carlo. He asks if you know, or when do you think this will be stable?
Well, I thought it was going to be stable until Google I/O, but well, Google I/O was canceled and it was supposed to be in a month, so it's not going to happen. But I think the team moved quite a bit forward in the last few months, so I think stable release maybe end of the year or so. I don't know. That's just by guessing on the state of the API, and but I think a beta can probably expect it like September or something like that. Maybe that means fully stable will be further away, but who knows? You can always ask on the Compose Slack.
Okay. Another question is how to keep modifiers from bloating your functions too much.
Well, extract them. You probably are gonna have some shared modifiers, like all of your cards or something like that. All of your paddings are gonna be the same somewhere, or all of your colors. So just extract them or make your own helper modifiers, which are a collection of often used modifiers.
Okay. And what's the plan for the graphical editor? Will it still exist alongside the text-based UI development process as it is now with XML?
Oh, I'm not on the Compose team, so full disclaimer if anyone thinks so, I don't know that. But yeah, I think they announced, well, the current editor is probably gonna stay 100%, but I think they also announced there's gonna be a Compose editor. I'm not sure about that. But there's also...
Doesn't the Canary version of Android Studio have already implemented like fully composed editor that you can like that has hot reload, so you annotate the composable function with some annotation and it does hot reload in Android Studio?
Yeah, no, it's the preview thing. So for example, if you have like let's say a composable comp and it only had, well, the thing is, okay, so let's have composable. So you have composables which don't have any arguments, and then you can use the preview annotation on it. And then we're gonna put something here. And yeah, that's composable. So style, do another text style. example. And it changes inside of Android Studio. This is great, but in that case, it will be great like while developing. So for example, you would take out these arguments and declare them and then use some mock data. But without the preview working with functions that have arguments, it's kind of useless for production.
Yeah, I agree. Miguel wants to know, are you going to share the code anywhere?
Okay, yeah, I will just clean it up and upload it on GitHub. I will share it on the meetup.com and I'll probably comment it or send it here in the YouTube chat.
Okay, great. Is there some new way to animate views with Compose?
Yeah, I think they have an animator component now, animated value, for example. No. I'm pretty sure I saw animations, but I still didn't use them. So I can't answer you that question, sorry. Let's see if we have anything. No. Yeah, I'm 100% sure they have them. I just can't find them right now.
Okay. So if there's no more questions from you guys, I want to thank all of you for coming and joining us today. Since this is our first online meetup, I really encourage you to leave us the feedback either here in the chat or in the meetup page in the comments. Also, I want to thank you, Ian. You agreed to hold this presentation. For me personally, it was great. And yeah, I hope this won't be our last online meetup. And we really need your feedback to make it better. So please, if you have some suggestions for us, leave them in the chat. And yeah, talk to you next time.
Thanks, everyone. Bye.
Bye.